10 facts about planet Earth you probably didn't know. Number 10. The planet isn't perfectly round. Since we were children, we've been taught that the Earth is a perfect sphere, a blue marble floating in space. However, the reality is slightly different and much more interesting. Due to the centrifugal force generated by its rotation on its own axis, our planet is visibly bulging at the equator and flattened at the poles. This phenomenon, known as the equatorial bulge, means that the Earth's diameter from pole to pole is about 43 kilometers shorter than its diameter across the equator. This bulge has surprising consequences. For example, the farthest point from the center of the Earth is not the summit of Mount Everest, the highest mountain above sea level. That honor belongs to the summit of the Chimborazo volcano in Ecuador. Because it is located almost on the equatorial line, its peak is more than 2 kilometers farther from the planet's center than the top of Everest, which technically makes it the highest point on Earth if we measure from its core. So, although to our eyes and on maps it appears to be a sphere, the Earth is actually an oblate spheroid. This imperfection is not just a geometric triviality, but a fundamental proof of the physics that governs the movement of planets. It's a reminder that even the most basic shapes we take for granted in the universe are molded by invisible and powerful cosmic forces. Number 9. The oceans hide the largest mountain range. When we think of great mountain ranges, the Himalayas, the Andes, or the Alps come to mind. But the longest and most spectacular mountain range on our planet is completely hidden underwater. This is the Mid-Atlantic Ridge, a gigantic system of submarine mountains that extends for more than 65,000 kilometers through all the world's oceans, like the seams on a baseball. If we could drain the water, it would be the most dominant geological feature on Earth. This colossal mountain range is, in essence, the birthplace of new oceanic floor. It is a divergent tectonic plate boundary where magma from the Earth's mantle constantly rises, cools, and forms a new crust, slowly pushing the continents apart. Most of this mountain range lies thousands of meters deep, but some of its peaks are so high that they emerge to the surface to form islands, as is the case with Iceland, which is one of the few visible portions of this geological wonder. The existence of the Mid-Atlantic Ridge was not confirmed until well into the 20th century, thanks to sonar technology developed during World War II. Its discovery was a key piece in confirming the theory of continental drift and plate tectonics, revolutionizing our understanding of our own planet's dynamics. It is a hidden world of volcanoes, valleys, and gigantic peaks that plays a crucial role in the shape and evolution of the continents. Number 8. A day on Earth used to last only 6 hours. We are accustomed to our 24-hour days, a cycle that dictates our rhythm of life, work, and rest. But this duration has not always been the same. About 4 billion years ago, when the Earth was a young and newly formed planet, its rotation was much faster. Scientists calculate that a day back then lasted approximately 6 hours. Our planet spun at a dizzying speed, which would have created constant hurricane-force winds and an incredibly short day-night cycle. The reason our days are now much longer is due to an unexpected cosmic player, the Moon. The Moon's gravitational pull on the Earth creates the ocean tides. This tidal friction acts as a brake, gradually slowing our planet's rotation over billions of years. This process, known as tidal braking, continues today, although it is imperceptible to us. Scientists estimate that the length of an Earth day is increasing at a rate of about 1.8 milliseconds per century. This means that in the distant future, days will be even longer. This fact reveals the delicate gravitational dance that exists between the Earth and its satellite, a relationship that not only illuminates our nights, but has literally shaped the length of our days throughout geological history. Number 7. The driest desert is a laboratory for Mars. When we think of the driest place on Earth, most people imagine the Sahara. However, the title belongs to the Atacama Desert in Chile. There are areas in this desert where not a single drop of rain has been recorded in over 400 years. It is a landscape so arid, so extreme, and so devoid of life that NASA uses it as a Mars analog here on Earth to test its rovers and search for the limits of life. The extreme aridity of Atacama is due to a double rain-shadow effect. On one hand, the Andes mountain range blocks moisture coming from the Amazon basin, and on the other, the Chilean coast range does the same with moisture from the Pacific Ocean. The result is a lunar landscape with soil so saline and oxidized that it strikingly resembles Martian soil, both in chemical composition and appearance. Despite these hellish conditions, life finds a way to subsist. Extremophilic microorganisms live inside rocks or in underground water pockets, offering scientists real hope that microbial life could exist or have existed in similarly hostile environments on Mars. Atacama is not just a record for dryness. It is a window to another world and a natural laboratory for answering one of humanity's biggest questions. Number 6. The Earth has a solid iron heart. The core of our planet is a place of mystery and extremes. It is divided into two parts, a liquid outer core and a solid inner core. This inner core is a sphere made almost entirely of iron and nickel, with a size similar to the Moon and a temperature that rivals that of the Sun's surface, reaching 6,000 degrees Celsius. The only reason it remains solid despite this infernal heat is the incredible pressure exerted by the planet's upper layers upon it. This solid heart plays a fundamental role for life on the surface. The liquid outer core flows around the solid inner core. This movement of molten metal, combined with the Earth's rotation, generates a dynamo effect that creates our planet's magnetic field. This field, called the magnetosphere, extends thousands of kilometers into space and acts as an invisible shield that protects us from cosmic radiation and charged particles from the solar wind. Without this solid core and the magnetic field that helps generate, the Earth's atmosphere would have been stripped away by the solar wind billions of years ago, leaving our planet a barren and lifeless world, similar to Mars. It is amazing to think that more than 5,000 kilometers beneath our feet, a ball of solid burning metal is the silent guardian that makes life on the surface possible. Number 5. The Great Oxidation, the event that changed everything. About 2.4 billion years ago, Earth's atmosphere was very different from today's. It was composed mainly of nitrogen, carbon dioxide, and methane, and was almost completely devoid of free oxygen. The life that existed was anaerobic microorganisms, for which oxygen was a deadly poison. But then, a type of bacteria evolved and changed the world forever. Cyanobacteria. These small organisms developed the ability to perform photosynthesis, a process that uses sunlight to convert carbon dioxide and water into energy, releasing oxygen as a waste product. For millions of years, these cyanobacteria pumped oxygen into the oceans and eventually into the atmosphere. This event, known as the Great Oxidation or the Oxygen Catastrophe, was the first and largest planetary-scale pollution event in history. For the existing anaerobic life, it was an apocalypse that caused a mass extinction. But for evolution, it was a revolution. The increase in oxygen allowed for the emergence of more complex and energy-efficient life forms, such as multicellular organisms, which would eventually evolve into the plants and animals we know today. We literally breathe the air that was created by a bacterial pollution eons ago. Number 4. There is more underground water than in the oceans. When we talk about Earth's water reserves, we immediately think of the vast oceans that cover 70% of the surface. But one of the most stunning revelations of modern geology is that there could be a much larger amount of water trapped deep within the Earth's mantle, hundreds of kilometers beneath our feet. This is not a liquid subterranean ocean, but rather water stored within the molecular structure of a mineral called ringwoodite. This deep blue mineral is found in the mantle's transition zone between 410 and 660 kilometers deep and is capable of absorbing water like a sponge. In 2014, scientists found the first direct evidence of this by analyzing a diamond from this depth that contained a small inclusion of ringwoodite with water trapped inside. Models based on this finding suggest that the total amount of water in the mantle could be up to 3 times greater than that of all the surface oceans combined. This discovery has monumental implications for understanding the planet's water cycle. It suggests that the oceans we see on the surface could have originated from within the Earth, sweating out water throughout geological history, rather than being brought exclusively by comets and asteroids. The planet's largest water reserve may, in fact, be right under our feet. Number 3. The mysterious hum of the planet. The Earth produces its own sound, a very low frequency, constant and mysterious hum or vibration that is below the threshold of human hearing. This phenomenon, known as the Earth's hum or microseism, was theorized for decades and finally confirmed in 1998. It is a permanent oscillation of the entire planet, as if a giant bell were perpetually vibrating. What is truly curious is that, for a long time, scientists did not know what caused it. Theories like atmospheric disturbances or earthquakes were ruled out, as the hum is constant and not dependent on these events. It wasn't until relatively recently that a plausible explanation was found: the clashing of ocean waves. The collision of waves traveling in opposite directions on the ocean floor generates pressure that is transmitted through the seabed, causing the entire planet to vibrate subtly. However, the mystery isn't entirely solved. Some research suggests that ocean waves only explain part of the phenomenon, and that other sources, perhaps of atmospheric or magnetic origin, might contribute to this planetary sound. The Earth, our seemingly silent home on a cosmic scale, is actually vibrating and humming constantly, a planetary background music that we are only just beginning to understand. Number 2. The planet once had a ring like Saturn. We associate planetary rings with gas giants like Saturn, but geological evidence suggests that our own planet may have had a ring system in its distant past. This theory is related to the formation of the Moon. The giant impact hypothesis, the most widely accepted today, posits that a Mars-sized protoplanet named Theia collided with a young Earth about 4.5 billion years ago. The impact was so cataclysmic that it vaporized Theia and launched a massive amount of debris from both bodies into space. Before this debris coalesced to form the Moon, it would have created a spectacular ring of rock and dust orbiting the Earth. For a time, which could have been months or thousands of years, our planet would have been the center of a dense and brilliant ring system, a sight that would have surpassed the beauty of Saturn itself. Eventually, gravity did its work. The debris in the ring began to clump together, colliding and merging into a larger and larger body, which ultimately became the Moon we know today. Imagining a primitive Earth with oceans of magma and a sky adorned by a majestic ring gives us a completely new and violent perspective on the origins of our world and its faithful celestial companion. Number 1. The Earth moves at 4 different speeds at once. We live with the sensation of being still, but we are actually participating in a cosmic journey at mind-boggling speeds. The first speed is the Earth's rotation. If you are at the equator, you are spinning along with the planet at about 1,670 kilometers per hour. This is the speed that gives us day and night. It's a movement so constant that we don't feel it, but it's faster than the speed of sound. The second speed is the Earth's revolution around the Sun. To complete its annual orbit, our planet travels through space at an average speed of 107,000 kilometers per hour. That's about 60 times the speed of a rifle bullet. Every hour, we cover a distance that would take us from one end of a continent to the other, and we don't even notice. But the journey doesn't end there. The third speed is the movement of our Sun, and with it, the entire solar system. Around the center of our galaxy, the Milky Way, we are moving at an estimated speed of 828,000 kilometers per hour. And finally, the fourth speed is the movement of our own galaxy, the Milky Way, through the universe. It is moving toward a massive gravitational point called the Great Attractor at an astonishing speed of approximately 2.1 million kilometers per hour. So right now, as you read this, you are spinning, orbiting, flying around the galaxy, and hurtling through the cosmos, all at once. That is the true nature of our journey through the universe.
Thank you for watching our video. Subscribe to our channel for more videos like this. Give it a like, comment your thoughts, and share this video with your friends and family.